Flutter architectures around state management has been a discarded topic. Having built a few mobile apps with various technologies, I found that certain principles will and should be present no matter what architecture or state management solution you choose. In this guide, I will show you a code structure, naming conventions, where to place files, how to keep things well organized and easy to maintain using the provider package. The provider package is basically Scope Model version 2. I've implemented apps in Redux, Block and Scope Model, and I still consider Scope Model to be the most practical and straightforward approach to build apps in Flutter. This goes for small, medium, large and massive apps, given that you follow some coding guidelines. This guide will have a very similar setup to my Scope Model guide with some changes to make use of the provider's functionality. Here's a preview of the app that we'll be making. The app consists of 3 screens. We have login, home and the post details screen. This app will communicate with a JSON placeholder API and get the user profile using the login ID entered on the login screen. The home view will fetch posts to display, and the post details view will display the basic post information and then fetch more comments based on the post ID passed in. To keep this tutorial focused on the architecture only, I have set up a starting project in the tutorials repo under folder number 10. Clone the repo in the description below if you want to follow along with the tutorial. The things that I've added into the repo start project has nothing to do with the architecture. Here's a list of the things that I've added for this project so we can skip over it while we build our architecture. We'll build out the architecture by implementing each view one at a time, and we'll start with the login view. If you will be following along, then I recommend opening the written tutorial, which is the first link in the description. You don't have to copy all the code from the monitor, you can just read the written and you can copy it from there. One quick thing, please subscribe to this YouTube channel and activate your notifications. We'll start off by creating a model for our login view. Go to the View Models folder and create a new file called Login Model. We'll create a new class called Login Model that extends the change notifier. We know that our model will have 2 states, so we'll also add an enum called viewState with the values idle and busy. Then go to the locator and register the model as a lazy singleton. Next up, we want to associate our login view with our new login model. Go to the login view and make the root of our widget a change notifier provider and give it a type of login model. We'll provide our builder with a value that we want our provider to give us, and that will be the model that's retrieved from the locator. The child of our change notifier provider will be a consumer that is of type login model. This consumer takes in a builder that returns our build context, our model and a child. For this builder, we'll return the scaffold, which will contain all of our views UI. This is the UI for the login view that we are building. We'll start by setting our background color to the background color from the app colors file. The body of the scaffold will be a column. The first child of the column will be the login header, and the second child will be the flat button that will perform the login. We'll set the button's color to white. We'll give it a text of login and set the style so the color is black. And we'll add our empty onPressed function, which we'll fill in later. Then we'll change our login view to a stateful widget so we can accommodate our text editing controller. We'll add a new controller variable called text editing controller, and we'll provide this controller to the login header. That will be all for the UI, and you can go back to the login model file. Let's add our state management code. We'll have a private variable called state that is of type viewState. Its starting value will always be idle, and we'll expose the state through a property called state. We mentioned at the beginning that we will always call notify listeners when our state has changed. For that reason, we'll wrap it in a function called setState that takes in a viewState value. And in this function, we will set our private value to the new viewState passed in, and we'll call the notify listeners function. Now that our state management is complete, we can move on to the business logic for the login model. Create a future that returns a boolean called login and that takes in the user ID text. The first thing we'll do in this function is to call setState and set our view to busy. Then we will convert the user ID text passed in into an integer. We'll do the error handling later, so for now we'll just stick to passing directly. Then we will take this value and we will pass it over to our authentication service, which we still have to create, and it will do the login for us and return success or failure to us in the form of a boolean. We'll inject our authentication service through the locator as a private variable. And in the login function, all we'll do is call the login function on the authentication service and pass in the user ID. And when this function is complete, we want to set the view state back to idle, and then we'll return the success value to our calling function. Go to the services folder and create a new file called authentication service, and then create your class to match. The service will be responsible for fetching and managing the user information. We'll inject our API through the locator, and we'll create our new future function that will return a boolean, and it takes in a user ID integer. Then we'll use the API to fetch the user's profile. We'll check if a user have been retrieved by checking if the value is null, and we'll return that value to our calling function to indicate success or failure. The API and the authentication service is being injected through the locator, so we have to go register them. Go to the locator file, and then in the setup locator function, we will register both of these services as a lazy singleton. Back in the user model, make sure that you import your authentication service. Go back to the login view, and we'll now call our login function from the onPressed callback. We'll make the function async, and we'll store the result of this call in a variable called login success. We'll call the login, and we'll pass in the controller.text value directly. We do this because we don't want to perform parsing or anything like that in our actual UI. That's all left up to the model. If the login was a success, we will navigate to our home view where we'll show the posts. The last thing we want to do in this login view is to make sure that our UI reacts to our state changes. We will check if the model state is equal to busy, and if it is, we will show a circular progress indicator. If it is not, then we'll show our flat button that we've just completed. Last thing is to make sure that our column is set to align all our widgets to the center. If you run this code now, you should see the login view looking like this. And if you put in a value like 3 and click login, you'll see the circular indicator showing, and then it's swapping back to the login when done. Now let's do some navigation. For the setup, I want to keep the navigation clean, and I want to use the push named route navigation only. The best way to use this is to supply the material app with a function that generates the routes for you through the onGenerateRoute property. This property requires a function that takes in route settings and returns a route of type dynamic. Go to the UI folder and create a new file called router. In that file, create a class called router where we'll create a static function that will generate our route. This function will return a route of type dynamic and take in a route settings parameter called settings. The settings passed to this function is the information that's associated with the requested route. And on the settings, there is a property called name, which will tell you what the name is of the requested route. We'll create a switch statement, and we'll switch on that name, and we will return our routes based on the name that's passed in. For our first route, we'll do just / and we'll return a material page route with a builder that will return the home view. For our second case, we'll do /login and we'll return a material page route that returns our login view. For our third view, we'll do /post and we'll return a material page route that returns our post view. We also want to indicate that if a route name does not exist, we'll show a little error page that says the view passed in does not exist. So for the default case, we'll return a material page route that returns a scaffold. The body of the scaffold will be a center widget, and the child of that center widget will be text that says no route defined for settings.name. Now head back to your main.dart file, and for the onGenerate route, pass in the router.generate route. And instead of returning a widget for home, we will now set our initial route to the /login route. That's it for all the navigation setup for the architecture. Go back to the login view, and in the onPressed, when the login is successful, we'll call navigator.pushNamed and we'll navigate to the home view using the /. If you run this code now and you click login, when it's successful, you'll be navigated to the home view. The navigation is done, the view model binding is done, and the dependency injection is wired up. The code structure is also where it needs to be. So next up, we'll make sure that adding new views and new models is easy in this architecture, and that we can have the same functionality for all views and models. We know that all views will require the same state management logic, so we'll move all the set state logic into a new file called base model. Create a base model class that extends the change notifier. Move all the state related code into the base model. We'll also move our viewState enum into a new folder called enums under a file called viewState. Just paste the enum from the login model in there. Then in the login model, we'll import our viewState and we'll change our login model to extend from the base model instead of the change notifier. Back in the base model, make sure that you import the viewState file. Now that the login model is a bit cleaner with less code, we can add our error handling. Create a new string property called error message. Then in the login model where we pass our user ID, we will check if the user ID is null. If it's null, it means that it's not a number. When this happens, we will set our error message and we'll say the value entered is not a number. Then we will set our viewState to idle so we can rebuild the UI, and we'll return false from the function to indicate failure. Then in the login view, you can now pass in the error message from the model as the validation message for the login header. If you run this code now and you enter text and press login, you'll see that there's a validation message that appears on screen. That's the only error that we'll cover, and you can add more if you want. I suggest wrapping the setting of the error message and the setState call into a function similar to setState, and then just calling that one function when you require to show an error message. The change notifier and consumer code will be the same for all of the views that has its own model. We'll take all of this code and we'll move it into a new file called base view. The base view will be a stateless widget. We'll make it generic and make sure that the type is of type base model. The consumer then requires a builder function, so we'll add a property that returns a widget and we'll call that builder. It will take in the build context, the model, and the child widget. We'll pass this value through the constructor, and then we can go to the login view and copy all of the change notifier / consumer code, and we can paste it in our build function. We'll change all the instance types of login model to type T, and for the builder, we'll pass it our builder that we just defined in the base view class. Make sure that you import everything that is required for the base view. Now in the login view, you can remove all of the change notifier code and replace that with base view of type login model. Fix up any bracket errors, and that should be it for the login model. Based on our design, we also want to make sure that the architecture provides for an easy way to call a function when a view is shown. The way this is done in Flutter is by calling your function in the init state override. We'll provide this functionality through our base view, so we'll change our base view to a stateful widget. We'll make sure that everywhere that the base view is used, we will pass in our type. The base view state class will be a generic class, and it will take in a type that extends the base model. Make extra sure that every section where the base view state is used passes in the correct type. Now we can add a new property that is a function and that takes in a model. We'll call it onModelReady, and we'll pass this in through the constructor of the base view. Then we'll override the init state in our base view state, and we'll check if the onModelReady function is null. If it is not null, we will call the onModelReady function and we'll pass it the model. The model of type T will store in the base view state as a local parameter, and we'll get it from the locator. We'll then call the widget.onModelReady with the model, and we'll also provide the model to the builder in our change notifier. Just as a quick test, I can show you that now wherever we use the base view, we have this onModelReady callback that will pass back our model, and we can use that to perform any starting logic call that we want to use. At this point, I can say that the architecture is basically complete, and the rest of the tutorial will just be showcasing how you can add new views and new widgets with models, and to see how easy it is to keep on extending this app. Next up, we'll build the home view, and we'll start with a home model as always. Create a new file called home model and create a class called home model and extend it from the base model. The home model will have the API injected into it using the locator. It will have a property that stores a list of posts, and it will have a single function called getPost that takes in the user ID. The first thing to do in this future is to call setState and set our state to busy, and then we'll use our API to get the posts and set it to our post property. And when all of that is done, we'll call setState again and set our view state to idle. Next up, we're gonna go and register our model in the locator as a factory. This is what we want our home view to look like. So head over to the home view and we'll start building the UI. We'll start by setting our root widget to the base view with a type of home model. Then in the onModelReady callback, we want to call model.getPosts. This call needs the user ID, so we'll have to find a way to get the user ID to the model. I don't want to inject the authentication service into the home model because it makes no sense if you read the code logically. So what we'll do instead is we will use a stream provider and we will provide a stream of user information through the stream provider. Go to the main file and wrap your material app in a stream provider widget of type user. For the initial data, we will pass in user.initial, which is a name constructor that I've created in the user model. And for the builder, where we provide our actual stream, we will get the authentication service and provide it with a user controller, which we still have to create. Go to the authentication service and create a public stream controller of type user called user controller. Then in the login function, we can now check if the return value has a user, and if it does, we will add that user onto the user controller. Now back in the home view, you can get the user stream provided through the stream provider simply by doing provider.offContext and passing the user value. Whenever this value is changed, this provider will update and rebuild this function, and so all we have to do is get the user and pass in the ID in the getPosts function. Now that all the setup is done, we can build the UI for the home view. The root of the builder will be a scaffold. We'll set the background color to our background color. For the body, we'll check the state and we'll see if it's busy. If the state is busy, we want to return a circular progress indicator in the center of the screen, and otherwise we want to return a column where the cross-axis alignment is set to start. The first child in this column will be a large vertical space from the UI helper. Then we'll add some text with some padding around it. The padding will be set to 20 and the style for this text field will be set to header style. Then we'll add another text with some padding around it and we'll just say here are all your posts. We'll give it a style of subheader style. Then we'll add a small vertical space from the UI helper, and the last child we want it to be an expanded child so it takes up the rest of the screen, and we'll return a list view from our getPosts UI function where we pass in all the posts. This function will return a list view builder. The item count will be the length of the posts, and for the item builder we will return a post list item and we will pass in the post using the index, and on tapped we will navigate to the /post route. We will also pass the post value to the arguments of this route. We haven't set up our router to actually extract arguments from our route settings. So go to the router file, and in the post case we can now use the arguments value and we can get the post that's passed to the settings out. Create a new variable called post and we'll get the arguments and we'll cast that to a post. Then we'll pass the post through the constructor of the post view. If you run the code now, you should be able to log in with a user ID between 1 and 10. And when you get to the home view, it'll load a little bit and then it'll show you all the posts for that user. Tapping on one of the posts will take you to a blank screen for the post. The post view will handle a little bit differently. The post view won't have its own view model. We pass the post data down through the constructor, so we have the title, the author and the body. The only thing that we need to fetch is the comments. Since the comments only relies on the post ID, we will create a widget that does all of this for us. Go to the View Models folder and create a new file called Comments Model. This class will extend the base model. We will inject the API into it using the Locator. It will have a property that stores a list of comments, and it will have one function called Fetch Comments that takes in the post ID. The first thing we'll do is set our state to busy, and then we'll fetch the comments using the API and we'll set that to our property comments, and at the end we will set the state back to idle. Now we can head over to the comments widget and we can make the root of this widget a base view and pass it the comments model type. Then in the onModelReady callback, we can now call the fetch comments and we can pass in the post ID that we passed through our constructor. The UI for this widget is also very simple. We want to check if the state of the model is busy. If it is, we'll return a centered circular progress indicator. If the state is not busy, we want to show an expanded widget. The child of this widget will be a list view, and the children of this list view we can map from the comments. So we'll map the comments on the model, and for each of the comments we'll return a comment item widget and we'll pass down the comment that is in the map function, and then we'll convert this to a list that we can pass to our children for the list view. Next up, we want to make sure that we register the comment model with a locator. Now we can finally build the post view UI. Since our post view doesn't have a model associated with it and just takes in a post, the build method will return the scaffold. We'll set our background color equal to the background color. Then we'll add a padding widget so that we can pad the entire view. We'll give it a padding of 20 on the sides, and the child of this padding will be a column. We'll set the cross-axis alignment to start, and then we can start adding our children. The first child will be a large vertical space. This will be followed by the post title that has a style of header style. Then we will display some very small text that says by the author name, and we'll get the name from the provider using the user type. We'll add another medium space. The next child will show the post body with some plain text, and the last widget will be the comments widget, and we can pass in the post ID. This is the end of the tutorial. So if you run this code now and you log in with any number between 1 to 5, you'll see that you get your posts. And when you go into a post, you will now see your comments as well under the post details, and underneath your title, you'll also see your author. The way that this architecture is set up, it works perfectly for small, medium, large, and very large applications. There's a few things that you might want to add, which is just grouping your files properly as your code base grows. For larger apps, you'll most likely have multiple widgets per view. So you can add folders under the widgets folder where you can group all of your widgets together per view. You'll most likely also have services and utils and then helpers as well. So your services folder can be split into a services and into utils and a helper folder. This will help you keep things organized so that you know what the functionality of each of your files are in the code base. Thank you for watching this YouTube video. If you found any value, please like and subscribe, and I will see you next week.